How are you all doing? Ralphy here, Ralfy Customs. Got a lovely project on next. We're working on decks. I call it a Batman bike, and it's fucking not. You'll know when you see the yokes, you'll see what I mean, yeah? So we're working on his yokes at the minute. We're going to do the middle and the back end as we work our way through the job. But for this week, I'm concentrating on getting his upside down and fuck off big thick slab Batman style yokes married up and the front wheel fitted and all that shizzle. So follow along and we'll see how it's done. Okay, here's the usual suspects. I've already had a quick investigation, yeah. And basically, right, here we go. We need to get this welded up. It's too thick for my TIG. That used to slot in there. Look, see what has happened there? Never a good idea. We're going to machine a thread. We're going to cut a thread on the end of this. And we're going to machine a boss that's going to press Loctite and grub screw into there. I was thinking of just cutting a thread in there, but it's a big chunk of shit to be spinning around on the fucking backing plate on my lathe, and I'm not sure about screwing into aluminium and screwing out of aluminium. You know, we'll do a steel boss. That's stronger. We'll look at. I'm not sure about this shit. I was going to go and spore weld it, but I might use low temperature aluminium soldering, I guess you'd call it. We just need some good filler in there just to make sure that nothing's going to go astray, and we'll pin and screw the boss that's going to go in there so it won't go anywhere. Yeah, so that's that. We need to look at the fitment of these in that, so it's not like that, is it? I'm going to measure those out and measure these, and they need to be a nice fit, and they need to have some form of deep grub screwy thing, you know. So if they're not right, I might have to get them on the milling machine and bore them out bigger and make inserts that are right. So that'll be really fucking interesting. Next is the state of these pinch bolts. These are the screws, none of them are the same. Not one of them's the same. They're the same thread. I'm thinking of checking them out and making them proper and drilling and tapping and sorting some fasteners out for them to make sure that they work, you know, because they need to. So then we can make a spacer. Let's come round. We can make a spacer for underneath, because this end of the shaft is going to come through this way, and we need to make a spacer to take this screw. That'll be how you tighten it down. A bit of Loctite on there or something to stop it coming undone. We'll make a little cap that sits in there, and so on and so forth. So there's plenty to go at just for that. We'll see what we uncover along the way. First up is I'm just running an M10 tap into these pinch bolt holes to make sure they all go down about the same length and that the threads are good and clean and all that. So far so good. This is number 2. That's just decked out there, look. That's bottomed out, and that's the same depth as the other one, but I had to cut some to get it, you know, so they weren't in the best shape. We've used a little bit of WD on there, as we do with aluminium. I could have used my alu fluid, couldn't I? Forgot about that. I will do them when I do the other side, eh? Sod the expense. So we're running a tap in, just to make sure that the threads are good. Bear with. And I don't know if the camera will get it, but there's not enough clearance. If you can, I can't really capture it. But basically, this part should be all clearance and this part should be threaded. That's tight. There's thread. Look, you can see there where the thread's caught on the edge of the hole. And deeper down, there's quite enough thread to catch the bolt. Now, unless you use a shoulder bolt, yeah, you're going to pick up on those threads. If you got this one goes in, and it starts to screw into the outer. Look, yeah, I'm not going to do it, but that'll go in there and it'll catch the thread in this part. So when you try and tighten it against this and squeeze the two together, you're binding up on itself. So we're going to address that. We're going to drill these out clearance, maybe on the milling machine. After I've tapped them, of course, so blow the shit out of that, and then we'll crack on and do the. So we've ended up over at the trusty pillar drill. Now, the reason is I need clearance. I need to be able to use a pin to line up the holes with the machine, and I need to be able to get that pin out, and I need clearance to clamp this in a vise. So we've come over here. I've found problem number 2 is, look, I put this pin fits nice in the threaded hole. It's not fucking straight. Look, I don't know if you can see that the camera's picking that up, but it's fucking like that. And that's the good one. Come over to this side. Look at the fucking angle of the dangle on that, boys. So I think I'm gonna have to be as precise as I can be, but I can't see me jigging this up on an angle plate and things to get it. I don't know, we'll see. Maybe I'll put some spacers under it. It's just a bit of a mess, to be fair. I think they're both in line. They're both perpendicular, if that makes sense. Both straight up from this angle, but they're really tight to the relief there. It's not been machined as well as it could be, let's say. So anyway, we'll get this jigged up somehow or another. We'll find a way of holding it, and we're going to put the clearance holes in this section, and then we're going to put relief in to take the head of the bolts to give it a bit of room so the threads actually can do their job. So we've sussed it. We've actually discovered that after 21 years, excuse me, there's an adjuster underneath. You can tilt the bed. So you can spin the bed, you can tilt the bed, you can alter the angle of the dangle. Fucking great bit of kit. So we've got that. I placed an old square. You could use an old rule, you could use a bit of scrap just through the slot there so the drill don't go all the way through. And then we can drill down to give that 10mm clearance. I'm not sure how we're going to go on when it comes to doing the relief for the heads, because we're really tight in there travel wise. You know, the bed of this is down as far as it'll go. I could sit the vise on the base of the machine, but then we wouldn't have the angle that we need, and we wouldn't have the reach either, then it's too far away. So I might end up putting an end mill either in this chuck or something else. It's most taper 3. I've got a collet holder that will fit in there, so I might end up putting an end mill in a collet holder in the drill to do the clearance for these, but we'll see. Let's get these drilled. So nice and steady. We've got a little stop there to make sure that we don't break through into the threaded part. All we can really do is kind of eyeball it and let it find its way. It's not too far out, so I'm hoping. There we go. That's on there, run it through, plenty of clearance. That simple. What I've done, I've ran the clearance through. Use a pin punch, transfer punch even, to fucking line up the holes, and angled me dangle and got them clear. What I've realised is that whoever machined them originally didn't leave a lot of fucking room. They've done them offset, basically. The relief for the head of the bolt is not central. It's well fucking wonky. It's actually bigger than it needs to be. So I'll show you in this one. Look, the bolt head clears easy, but when it's threaded in, it binds up. Now I've not got room to get in. I simply can't get in. I've not got a cutter that's the right size either. So what I've elected to do is take these bolts, turn the head down a little, so it gives us some clearance, and at the same time I need to take a little bit off the end because they're a little bit long. So I've used my patented screw 3 nuts on to make a mandrel, and that'll sit in the chuck of the lathe quite happily while I take a skim cut off, and then I can take it out, take it over to the vise, cut that off, clean the end up, unscrew the nuts times 4. So I'm going to make 4 special bolts out of these bolts. This should do the job very, very nicely. That's the plan. Okay, so I'll put 3 nuts on the bolts, just the one bolt at the minute. 2 are held firm, this one's a bit of a spacer, and then I can just go in and machine a little bit off this head. I'm going to take it down from the size it is now to 15 millimeters. So I'm just taking a couple of millimeters off there, a little bit less than 2 mil, and that'll hopefully give us the clearance that we need to fit nicely in that yoke. Let's have a look what we've got. We are on 15.4, so half a mil, 20 thou, so we need a 10 thou cut on this old girl. She's there. No way she blows. Yeah, a little bit of resistance there as it's screwed into the nuts, so we'll take a spring pass. It's not precision, it's just the clearance, and we're away. And we'll do that with the others. Trim a little bit off the end, give them a clean up, and then they should be ready to fit in the yoke. So there we go. There's the 4 special bolts. We'll pick that one up in a minute. 3 special bolts. Turned down, deburred, trimmed and chamfered, and they're going to go in there without too much binding. So that bit's done. So next on the agenda is that the problem here is that this hole for the bottom of the steering stem is an interference fit, which doesn't mean that you can put it together and adjust anything really. I don't get, they must have had to press it together and go on shims and spacers and things, I don't know. Anyway, so what I've done, I've got it in the mill, just fits in the vise, and it's got the 2 points on the back, the backman sign, and a good chunk at the front, and I've dialed it in to within 1/10 of a thou, less than 1/10 of a thou. Well, it's not focusing very well, but we're on 0 all the way around, near enough, within 1/10 of a thou. I'm going to lock the bed off, and I'm going to get a boring bar in and give it just a tiny fucking skim. That's all it needs, it's a tiny skim. There we go. That might have just done it enough. Now, unfortunately for me, I've not got a DRO, so I can't move the piece. I can't move it out of the way to try the fucking spindle in, can I? No. So I have to measure it. We'll use numbers. A digital vernier on it, yeah? And we were to say 29.8. 29.8, just over. Which is the size for the bearing, fits the bearing. So obviously it all needs to be a little bit bigger than that. And that at the minute we're at 29.4. We just took a slight skim off at that. 29.6, so we want 0.2, which is 0.1 each side. Near as fuck it is to swearing. So we just need a little skim off. We've done a clean up pass. We need a tiny little bit. I'm just going to move it about 3 graduations. 4, I've got 4 graduations, which is 0.08, which is 0.16 of a millimetre off the diameter. There we go, nice little spring. It's literally just a bit of a clean up, just to get it a bit of clearance for the stem. There's a recess at the bottom, so we know we're clear. We don't need to worry about catching anything underneath once we get down to it. Yeah. And now we'll back it out, measure it up, rinse and repeat. There we go, nice and steady. It's fucking not round. The hole's not round, no surprise there. What I would do, if this was a more accurate job, I'd set a dial gauge up here, off a magnet base or off the back here or something, and then wind it across and use the gauge. You know, that's going to tell me how much I'm moving it when I need to be super accurate. But it just needs to be a clearance. It literally needs to be round and a clearance size. So let's see what we've got, eh? We've now got 29.78. Fucking hell. What's this? 29.8. So we're nearly there. I'll take another little spring pass off camera. Maybe adjust it a little bit, but you get the message, you know. You see how it's done. Now, we've done that. We've bored that out, cleaned it all up. That fits in just fucking super. That does. It's gonna hold its place nicely. What we need to do now is work out a fixing for the top. I think what I'm going to do, I'm going to turn this down and I'm going to cut an M20 thread in the end of it, and then I'm going to make a bush that screws on, and then we're going to set it in the top of this yoke once this repair's done, so that'll screw in there tight. We'll pin it with a couple of sideways grub screws. Not sideways, they go down the side between the bush and the body of the thing. Keyed in is a more better way of explaining it. But right, so we've got to machine this round to 20mm diameter, just under 19.98 or something. We're going to cut a thread on it, 28mm down from this end. So it's going to be a bit rough while I do an interrupted cut, but I'm sure the old gal handle it, eh? Get her in gear, get her fired up, and off we fucking go. I'll keep roughing away at this. I can take a bigger bite of this cherry than that. Oh no. 0 me 8, let's have a look. We'll go 40 thou cut, see what that's like. Oh, that's quite comfortable. Probably go a little bit deeper, and you can join me again once we get down to round. We've stepped it up to 80 thou cut, as the diameter's got a little bit smaller, but we've still got a little way to go. And now we're about down to round. I did set the DRO when we faced across to 0, so I know I need to go 28. I'm just going to take another little pass, and then we'll have a measure up, see how much we need to take off. I don't know what they made this from, but it's quite tough stuff. There's plenty of blue chips been flying around. So that is 28.11. And we need to take it down to 19.8. So we'll get on with that. and I'll see you when we've got it down to size. So we change bits over to a smaller tip. So we're getting down to size, so we're getting nice and finished. Although these chips, look how long that is, look. It's red hot as well. So you don't want that wrapping around your wrist, do you, as you're working away? It's fucking hot. We'll keep going until we get it down to the size, and then we'll prep it for thread cutting. Right, so we're all set up. We've cut a relief for the thread. We've marked it black. We're going to do a scratch pass just to check that our pitch is right. And I've changed up. I'm going to go 1.5 pitch because I think that'll be better. I think of course is better, you know. So we're going to go 20 by 1.5 along here, and then we're going to make a nut, well, an insert for the top yoke that's going to screw on there, and set it into the top yoke. It's going to move here. Righto. So we're all geared up. I'm going to wait for my line to come round. Do a scratch pass. Here we go. It's a bit fucking fine to me, to be fair, like, but we'll see. Get to the end. Close off. Back out. Reverse. Away she goes. Back again. So I'll check that pitch. And if it all works out fine, then we'll get cutting, eh? So that's all good. We're all sorted. I'm sure you've seen a lot of screw cutting, so I won't bore you with it. There's a million videos. Check out Joe Pysinski, yeah, out of Advanced Innovations in Austin, Texas. He sets it upside down and runs away from a shoulder like this, which is genius. But I'll do a couple more passes and then we'll cut to when I've cut it, because you've seen threads being cut, you know what I mean? So what I do is leave it engaged and ride the clutch. So I'll feed it in, look, and never disengage the screw. Run the machine in reverse, back out, clear the job. But you can't see any of this shit, and I'm fucked from working around the camera while I'm screw cutting, so I'm afraid what you see is what you fucking get. What is that? 0.25. We'll go another half a mil deeper on now, and we just keep running it on the clutch, backwards and forwards, backing it out and then feeding it in, backing it out and feeding it in. Then there's absolutely no room for getting your knickers in a twist when you're trying to catch a number, or if you get distracted or whatever, you know. So it's if you check out Carl, his name's Curtis, everyone calls him Carl. Check out Curtis and Karen, Cutting Edge Australia. If I remember, I'll link in, and he touched on it, and that's how he was taught, and I've embraced that, because I think for me it just makes sense, you know. Don't disengage your lead screw and just work your way backwards and forwards. It just seems the sensible option. I don't know why everybody doesn't do it that way. Right, now last cut. Let me just spin you around. Here we go. So we're all set. We're on a final depth that you probably can't read because it fucks with the screen. And I'm going to feed you in. Turn the lathe round the right way. And we're just doing a final cut, little spring pass. So hopefully this will stay focused while I do it. Not that great, but we're on it. End it out, and that's the thread done. So now we've cleared the threads and the reliefs and got the pinch bolts sorted. We've sorted the stem clearance out in the bottom yoke, so we can make some cup adjusters type things once it's all together, and we've cut the thread where it's going to affix into a boss into the top yoke, which is what we're going to make next. So we're getting there. Abso-fucking-lutely. Okay, so now we're going to make the insert, the nut bit, if you like, to the stem. I've already taken the liberty of facing it off a bit of stock, centre drilling it and then pilot drilling it in 10mm. The size I need to cut that 20mm thread is 18.5, and I don't have one. I've got an 18mm drill bit which is in. I'm hoping it throws a bit and gives us that extra to save me having to bore it with a boring bar, but if I need to, I need to, you know. So I've kept you where you are, so I think you can see a bit better. Let me know in the comments if you prefer this view on the lathe, because I always think you can't really see shit. It's really hard to position the camera here. Anyway, we're going to go to a depth of 40mm. We need to make an insert that's 30mm long, with a little step on there, so 34mm-ish. Not critical, because we'll machine the yoke to match the insert. So let's see how this 18mm bit goes. I'm going to chatter a bit at first, as you always do. Oh, that actually feels too smooth to be cutting a hole that's too big. Just be my luck, wouldn't it? I go, yeah, I've got one. Does he throw any? Is it big? No, it cuts lovely. Anyway, slow things down, nice and steady. We'll drill this out, smoky goes, and then we'll have a measure. And we might need to go in there with a boring bar. I'm just looking across my tooling as I'm doing this and thinking to myself, I've not got a boring bar that small over here. I might have to go and rob one off the little Atlas. Anyway, that's that. Let's see where we're at. So we want 18.5, and this is going to be a bit small, you know, it's warm. It's 17.8. Oh, hold on, I need to zero. It's going to be worse. I'm losing. I'm losing size. The incredible shrinking hole. We want 18.5 on the very near, and we've got 17.8, 17.9. So yeah, we're gonna have to bore that out. Now, would you fucking Adam and Eve it, as my old man, are you gonna say, used to say, as my dad says, would you fucking Adam and Eve it? I've got one. It just fits the boring bar off this machine that I've got set up. I've got 2 or 3, and this is like the smallest one. It just fits in that 18mm. It's the minimal hole, so there you fucking go. So we can run this up, and we can just touch off on that, you know. It's going to take a very, very light cut, just to true it up. And we'll feel it bump out. Now I've drilled the old over depth, so you don't have to worry about the finish at the end. And before we cut our thread, we'll part this off and have it exposed to air, both ends exposed. So that's going to be dead end. So we'll zero the X and zero the Z, and everyone's happy. We can go from there then, can't we? So we can fuck that off out of the way. We can measure this. What do we want? 18.5. We've got 17.94. We'll call it 17.9. So we'll enter that. 17.9. Enter. And we want it 18.5. So here we go. Take a bit of a cut then. We'll go out to 18.4 and then out for a couple of spring passes or whatever. It's just a very light stem, and I'm counting down the Z feed. You can't see it, so I'll keep an eye on that. You keep an eye on the tooling. When we get to zero, we'll knock it off, back it out, and run it in again just to be sure. And we're nearly there. 5, 4, 3, 2, 1. Boom. There you go. Clean that shit off. Do it all again. Hang on, bear with. This should give us 18.5 bob on. 18.48, 18.49. That'll do me. That'll do me. So 3/10 of a mil, or maybe 2/10 of a mil shy. The spring passive, 18.5 I've got there. The old verniers are not the most accurate, but they'll do for this. I'm only going to cut a thread down there. So now we can machine the outside down to whatever size we fancy. Well, we're doing 20, so we'll allow 4 mil each side, 28 mil. What does this measure? Yeah, this measures 30. No, we'll go smaller. We'll go a little bit smaller so we've got more of a step left on. Oh, we'll see. We'll see, I'll work it. But we're ready to rock and roll on the outside now. Okay, so what I've done, I've turned this down to 28 millimeters, and I'm going to leave it just straight. I'm not going to leave it a step. I'm going to have it just a smooth, straight bush, if you like, threaded bush. That way, I can drill a couple of, drill and tap 2 drug screws halfway between the joints, right down the joint, and that will stop it spinning. You might say, why did I just not leave it stock size 30 millimeter? But I want to make sure that this edge, the outside diameter, is concentric to the threaded part, so it's not on the piss. So I've just machined that hole out. It wasn't there before, and it might not be quite true. It's just good standard engineering practice. What I need to do now is find me tool for changing bits and drop parting off tool in. So there it is. Drop my parting off tool in. Make sure that it's square to the job, which it is. The tip don't look great, but I think we'll be alright. And we're going to have it off there. It's going to slow things down a bit. Just do it. Lock the bed off. Put the saddle. And where's your blows, Captain? And once this is parted up, we'll spin it round, clean the end up, probably put a bit of a chamfer on the edge of the hole, and then go in search of an internal threading tool. I've got one here, but I'm not sure it's going to give me the clearance that I need. I've got one that takes carbide inserts across the way. I might try that. See how it goes, eh? Meantime, let's get this bit off. It's all done. Sorted. So we'll just clean this up. Quick face off. Quick break the edge with a file. And chamfer the inside. Now we need to find a tapping tool, an internal threading tool, so we can tap that out to our desired size. Would you believe it, I found one. Little tiny one that just fits lovely with a carbide insert, so it's a winner. Another thing, again, there's a million threading screw cutting videos on their YouTube, so this 30 degree, 28.5 degree, blah blah blah. If you're using a carbide insert, in my opinion, they're pre-formed to the profile to go straight in, straight across or straight out. You don't need to feed them across at an angle to make the profile of the thread. So I don't bother. I do it all on the cross line. Don't bother with the compound. There you go. Anyway, so we're all set. It's really tricky to see in there to do a scratch pass and check it, but we'll do our best. We'll hit a number, we'll do it just like before, engage the lead screw, leave the lead screw engaged, ride it out on the clutch. Here we go. Scream if you want to go faster. I'll tell you what, I've not fucking checked that I'm going to reach the bottom alright without crashing the fucking tool, which I'm not sure if I am. I think I've just down. Woohoo! There you go. So now we can wind that across, reverse the action, leather it back out, give it a check, get cutting them threads. I'll join you again once we've got on with that, ain't it? Now I think we're about there. We've done a few passes and we're out to 19.8 and a bit. So I've not moved. Hold on. Need to move the carriage back a bit more, so I can get in with this and give it a test. If anything, it's going to need a little bit more, but maybe just a spring pass. So far, so good. That's all right. I like that. There you go. So we've successfully threaded the end of the shaft, whoever this is, and made a boss that we can fit into the yoke to secure it in place. Let's have it out the truck. There you go. Nice one. So now I think this is where the problems begin. We need to find a centre for this job here. I'm going to try and mount it on the forks, push the things through, do all that, see how well they line up. But initially, my initial indications are, I don't know if you can see, but there's a gap there to the left and not much of a gap to the right. And when we come over here, it's the same issue. There's a gap to the left. Sorry, very little gap. There, it's almost smooth, it's almost flush, the two holes, and there's a fucking step there. So, I don't know if they're parallel, perpendicular, going to line up, and see what we can do.